Take a slow, deep breath in and gently let it go. Allow your shoulders to relax, your jaw to soften, your eyes to rest. There is nowhere you need to be right now, and nothing you need to do. Tonight, we will drift through space together toward a quiet, rust-colored world known as Mars, a planet that has fascinated human curiosity for thousands of years, yet remains patient, silent, unchanged by our wonder. As you listen, you may notice gentle pauses between the words. These moments of silence are intentional. They give your mind permission to rest, to wander, to simply be. If your thoughts drift away, that is perfectly fine. There is no wrong way to listen. Simply return your attention to the sound of this voice and the slow, steady rhythm of your breathing. Let yourself become weightless, as if you are floating gently upward, away from the concerns of the day, towards something vast and peaceful. Mars is often called the red planet. Its soft red glow comes from iron oxide, essentially rust, covering much of its surface like a fine ancient powder. Long before telescopes existed, long before cities filled with light, ancient civilizations would look up at the night sky and notice this red light moving slowly among the stars. To the Romans, it was named after Mars, the god of war, drawn by its color, the color of passion and fire. To the Egyptians, it was known as Herdesher, the Red One. To others across time and cultures, it symbolized energy, change, and mystery. But tonight, we see Mars differently. Not as a symbol of war, but as a quiet companion, drifting through the darkness of space. Mars appears brighter than most stars, not because it burns with its own light, but because it reflects the gentle warmth of our sun. At certain times, Mars comes closer to Earth in an event astronomers call opposition. During these moments, it becomes one of the brightest objects in the sky, glowing softly overhead like a distant ember. And then slowly, It moves away again, fades gently, almost as if the planet itself is breathing in and out with the cosmos. This dance has continued for billions of years, long before any eyes watched from Earth, and it will continue long after. There is something comforting in that rhythm, something that reminds us we are part of cycles far greater than ourselves. Mars is, on average, about 140 million miles from Earth. To imagine this distance, picture traveling at highway speed without ever stopping. It would take more than 160 years to reach Mars. Even light, traveling at the fastest speed possible in our universe, takes between 3 and 22 minutes to reach Mars, depending on where the planets are in their orbits. This means that every image we receive from Mars, every photograph taken by our robotic explorers, is already part of the past. When we look at Mars through a telescope, we are seeing it as it was minutes ago. A gentle reminder that space and time are woven together. A year on Mars lasts 687 Earth days, nearly twice as long as a year here at home. Mars moves more slowly around the Sun, tracing a calm, elongated orbit through the vastness of space. If you lived on Mars, seasons would stretch and linger. Autumn would last for months. Winter would settle in slowly without hurry. Time itself feels different on Mars. Stretched, unhurried, patient. There are no clocks ticking on Mars. No schedules to keep. Only the slow rotation of a planet beneath distant stars. Let yourself imagine what that might feel like. A world where time moves at its own pace, where there is no need to rush. Ever. A single day on Mars is called a sol. One sol lasts about 24 hours and 39 minutes. Just slightly longer than a day on Earth. As if Mars is taking a little more time to breathe. This makes a Martian day surprisingly similar to our own. Familiar yet subtly different. If you stood on the surface of Mars and watched the sun rise, the sun would appear about 2/3 the size it does from Earth. It would rise slowly, casting long, quiet shadows across the rust-colored surface, painting the landscape in shades of amber and copper. The light would feel softer than on Earth, more distant, but still warm enough to touch the rocky ground. As the day progresses, the sun would arc gently across the sky, moving through thin wisps of clouds made of water ice. And then, in the evening, something remarkable happens. Sunsets on Mars appear blue instead of red, while Earth's sunsets glow with oranges and pinks. Mars reverses this. The sun sinks toward the horizon surrounded by a soft, cool blue haze. This happens because fine dust particles in the Martian atmosphere scatter sunlight in a gentle and unusual way, filtering the light until only the blue remains. Imagine standing there in the dimming light, watching a blue sunset on a red world, feeling the temperature drop as darkness slowly arrives. The stars would emerge one by one, brighter than you've ever seen them from Earth, undimmed by thick atmosphere or city lights. And you would stand in perfect stillness, beneath a sky filled with ancient light. The surface of Mars is a landscape of extremes, yet it invites a quiet kind of contemplation. Mars is home to the tallest volcano in the entire solar system, a mountain called Olympus Mons. Olympus Mons rises nearly 16 miles into the Martian sky, almost 3 times higher than Mount Everest. And yet its slopes are so gradual, so gentle, that if you were climbing it, you might not realize you were on a volcano at all. You would simply walk upward, slowly, for hundreds of miles, the horizon always appearing flat before you. From orbit, Olympus Mons casts a shadow, so large it can be seen from space. A dark circle, stretching across the planet's surface. This ancient volcano has been silent for millions of years, waiting, resting, covered in dust that settled grain by grain over unfathomable spans of time. Mars also contains a canyon system called Valles Marineris, the Valley of the Mariners. This canyon is so vast, so impossibly deep, that it would stretch across the entire United States if placed on Earth. In some places, Valles Marineris plunges 4 miles into the planet's crust, its walls layered with different colors of rock, each layer a chapter in Mars's ancient history. These formations were shaped by forces that acted slowly, tectonic shifts, water erosion, all working patiently over billions of years. Nothing on Mars happened quickly. Everything you see there is the result of time, moving at a geological pace, a pace that makes a human lifetime seem like the briefest flicker. The ground of Mars is covered in fine, powdery dust, reddish-orange, soft as talc. It clings to everything it touches. This dust is so fine that it can remain suspended in the air for weeks, especially during the planet's dust storms. Sometimes these storms grow and grow, spreading across regions, then hemispheres, until they envelop the entire planet in a hazy amber veil. During a global dust storm, the features of Mars soften and blur. Mountains disappear. Canyons fade. Everything becomes one unified dreamlike haze. And then slowly, the dust begins to settle again. It drifts downward like snow, coating the rocks, filling in footprints left by rovers, returning the planet to silence. Scattered across the surface are rocks of every size, some smooth and round from ancient water, others jagged and sharp from meteor impacts. There are fields of dark volcanic rock, plains of wind-blown sand, and vast stretches where nothing changes for thousands of miles. It is a lonely landscape, and yet there is something peaceful in that loneliness. Water is the key to understanding Mars. For much of its history, scientists believed Mars was a dry, dead world, unchanging and barren. But over the past few decades, robotic explorers have found strong evidence that water once flowed freely across the Martian surface. Dry riverbeds wind across ancient plains, their channels still visible after billions of years. Smooth, rounded stones sit in patterns that could only have been shaped by flowing water. There are deltas, where rivers once emptied into lakes, depositing layers of sediment in fan-shaped formations. Some scientists believe that billions of years ago, Mars may have had an ocean, covering much of its northern hemisphere. Deep and dark and full of possibility. Imagine that ancient Mars, a younger planet, wrapped in a thicker atmosphere, beneath skies that might have been blue. Rain may have fallen there. Waves may have lapped against rocky shores. Rivers may have carved their way through valleys, just as they do on Earth. But slowly, Over millions of years, Mars changed. Its magnetic field weakened, allowing solar wind to strip away much of its atmosphere. Without a thick atmosphere to hold warmth, temperatures dropped. The water began to freeze, to evaporate, to disappear. Today, water still exists on Mars, but mostly frozen, hidden beneath the surface, and locked in the polar ice caps. At the north and south poles of Mars, vast ice caps glow white against the red landscape. These caps are made of both water ice and frozen carbon dioxide, layered like the rings of a tree, each layer recording ancient climate cycles. In the Martian winter, the ice caps grow larger as carbon dioxide freezes out of the thin air. In summer, they shrink again as the ice sublimates directly into gas, never becoming liquid. Beneath the surface, ground-penetrating radar has detected what may be vast reserves of frozen water, waiting, silent, preserved in the cold Martian soil. And in some places, during certain seasons, something remarkable happens. Dark streaks appear on Martian slopes, flowing downward like fingers reaching toward lower ground. These streaks, called recurring slope lineae, appear in warm seasons and fade in cold ones. Scientists believe they may be caused by briny, salty water, just concentrated enough to remain liquid for brief moments, seeping slowly through the soil. It is a reminder that Mars is not entirely still. Even now, the planet holds secrets, small signs of change, whispers of possibility. Water connects Mars to Earth in a quiet, meaningful way. It reminds us that planets, like people, can change over time, can lose things, can carry memories of what they once were. Mars has a very thin atmosphere, so thin you could barely feel it. It is made mostly of carbon dioxide, the same gas we exhale with each breath. But on Mars, this gas makes up 95% of the air. The air pressure on Mars is less than 1% of Earth's. Standing on the surface would feel almost like standing in a vacuum. The air too thin to breathe, too thin to carry sound very far. If you shouted on Mars, your voice would sound muffled and distant, swallowed by the thin air. And yet, this thin atmosphere still creates weather. Winds on Mars can reach speeds of 60 miles per hour or more, racing across plains and over craters. But because the air is so thin, even strong winds would feel gentle, like a soft breeze brushing against you. These winds are what shape the surface, lifting dust into the air, carving patterns into sand dunes, slowly eroding ancient rock. Clouds form on Mars, delicate wisps of water ice, drifting high in the atmosphere. Sometimes they gather near the peaks of tall volcanoes, spilling over the summits like waterfalls frozen in time. And sometimes, snow falls on Mars. But this is not the snow we know. Martian snow is made of frozen carbon dioxide, dries, falling in tiny flakes that would sublimate before ever reaching your hand. In the coldest hours before dawn, frost can form on the ground, delicate patterns of ice crystals glittering in the low light. Mars experiences seasons just like Earth, because its axis is tilted at nearly the same angle. But because a Martian year is so much longer, each season stretches and lingers, autumn deepening slowly into winter, spring arriving without hurry. The weather on Mars is predictable, calmer than Earth in many ways. Yet occasionally the planet surprises us. Dust devils spin across the surface, tall columns of swirling dust that can reach several miles high, twisting gracefully before dissipating into stillness. There is a rhythm to Mars, a slow, steady pulse of wind and dust and ice, all moving according to laws older than memory. Mars has two small moons, Phobos and Deimos. Their names come from Greek mythology. Phobos meaning fear, and Deimos meaning dread, the twin sons of the god of war. But there is nothing fearful about these tiny moons. They are irregularly shaped, like floating stones, tumbling gently through space. Phobos, the larger of the two, is only about 14 miles across. Its surface is covered in craters and grooves, scars from billions of years of slow impacts. Phobos orbits very close to Mars, closer than any other moon orbits its planet in our solar system. It moves so quickly that it rises in the west and sets in the east, the opposite of how our moon moves across Earth's sky. In fact, Phobos completes an orbit in just 7.5 hours, rising and setting multiple times in a single Martian day. From the surface of Mars, Phobos would appear much smaller than our moon, about 1/3 the size, crossing the sky like a swift, silent companion. And Phobos is falling, very slowly, inch by inch. It is spiraling closer to Mars. One day, millions of years from now, Phobos may break apart, pulled apart by Mars's gravity, forming a ring around the planet. Deimos, the smaller moon, orbits farther out, moving more slowly, more gently. It is only about 8 miles across, barely large enough to be round. For Mars, Deimos would look like a bright star, steady and calm, rising slowly in the east and setting in the west like our own moon. These two small moons are likely captured asteroids, pulled into orbit long ago, now bound to Mars forever. They serve as quiet guardians, watching over the red planet as it turns beneath them, patient and unchanging. For thousands of years, Mars existed only in our imaginations. Then, in the 1960s, humanity sent its first robotic messenger across the void. Since then, dozens of spacecraft have traveled millions of miles to reach Mars, some to orbit above, others to land gently on its surface. These robotic explorers move slowly, carefully, studying rocks and soil with instruments more sensitive than human hands. Rovers like Spirit, Opportunity, Curiosity, and Perseverance have driven across plains and climbed hills, leaving tracks in the dust that may remain for centuries. Each discovery is made patiently, one careful moment at a time. A rover might spend an entire day analyzing a single rock, brushing away dust, taking photographs, measuring its composition. There is no rushing on Mars. Every movement must be planned, every action deliberate. And through these patient explorations, we have learned that Mars is far more complex than we ever imagined. We have found minerals that form only in the presence of water. We have detected organic molecules, the building blocks of life, preserved in ancient rocks. We have measured the atmosphere, mapped the surface, and listened to the wind. A small helicopter named Ingenuity became the first aircraft to fly on another planet, lifting gently into the thin Martian air, hovering for just a few seconds before settling back down. Even that brief flight was a triumph, proof that exploration is possible in ways we are only beginning to understand. These missions teach us that curiosity does not need to rush. Discovery unfolds slowly, question by question, image by image, year by year. And perhaps that is the greatest lesson Mars offers us: patience. We have traveled far tonight, across millions of miles of space, to visit a quiet, ancient world. Mars waits there still, turning slowly beneath its distant sun, wrapped in dust and silence. It does not hurry. It does not worry. It simply exists, as it has for billions of years, and as it will for billions more. There is something comforting in knowing that Mars is out there, distant neighbor, patient and still, following its orbit through the darkness. As you let yourself drift towards sleep, carry with you the image of that rust-colored world, the blue sunsets, the towering volcanoes, the ancient river valleys. Let yourself float gently, as if you were looking down at Mars from high above, watching it turn slowly beneath you. There is no need to think about tomorrow. No need to solve anything tonight. Simply rest in the stillness, in the quiet company of a distant planet, in the vastness of space, where time moves slowly, and everything is exactly as it should be. Take one more slow, deep breath in, and let it go. And now, let yourself sleep. Mars remembers everything. Unlike Earth, where wind and rain and living things constantly reshape the surface, Mars preserves its history in stone. The rocks on Mars are old, some more than 4 billion years old, nearly as ancient as the solar system itself. When scientists study these rocks, they are reading a story written in layers, each stratum a page from Mars's past. The surface is divided into distinct regions, each with its own character, its own quiet personality. The southern highlands are the oldest parts of Mars, heavily cratered, rough and worn, like the weathered face of time itself. Every crater tells a story of impact, of asteroids arriving from the darkness of space, colliding with Mars in brilliant, silent explosions. Some craters are small, just a few feet across, barely noticeable among the rocks. Others are massive, hundreds of miles wide, their rims rising like mountain ranges around deep, shadowed floors. One of the largest is Hellas Planitia, a basin so deep that if you stood at its center, the atmospheric pressure would be twice as high as anywhere else on Mars. The northern plains are younger, smoother, covered in volcanic rock that flowed like slow rivers of stone billions of years ago. These plains stretch for thousands of miles, flat and featureless, a landscape of profound simplicity. Between the highlands and the lowlands runs a boundary, a gentle slope that circles the entire planet, evidence that Mars is divided into two distinct hemispheres. Scientists still wonder why this division exists. What ancient process shaped Mars this way? Some believe a massive impact, larger than any crater we can see, once struck the northern hemisphere, creating this fundamental asymmetry. Scattered across Mars are formations called chaotic terrain, regions where the ground appears to have collapsed, leaving behind a jumbled maze of blocks and valleys. These may have formed when underground ice suddenly melted and drained away, leaving the surface to fall into the emptiness below. Mars also has sand dunes, fields of them, dark and rippled, shaped by winds that blow in patterns, unchanged for millennia. Some dunes are hundreds of feet tall, their slopes smooth and perfect, curves sculpted by invisible hands. In satellite images, these dune fields look almost like fingerprints, unique patterns pressed into the surface of the planet. And everywhere, covering everything, is that fine red dust, settling into every crack and crevice, coating every rock, painting the entire world in shades of rust and amber. One of the deepest questions we ask about Mars is simple and profound. Did life ever exist there? We do not know the answer yet, and perhaps we may never know with certainty. But the question itself draws us back to Mars, again and again. Life as we know it requires a few essential ingredients: liquid water, organic molecules, and energy. Ancient Mars had all of these things. Billions of years ago, when Mars was younger and warmer, when water flowed across its surface, the conditions for life may have existed. Scientists have found rocks on Mars that contain minerals formed in hot springs, environments on Earth where life thrives, even in extreme conditions. They have discovered organic compounds, complex carbon-based molecules, preserved in sedimentary rocks. These molecules are not evidence of life, not by themselves, but they are the building blocks from which life could emerge. The Curiosity rover drilled into the floor of Gale Crater, a site that was once a lake, and found layers of mudstone that formed in calm water. These layers show that the lake was stable, not just a brief flood, but a body of water that persisted for thousands, perhaps millions of years, long enough for life to begin, if it was going to begin at all. The Perseverance rover is currently exploring Jezero Crater, another ancient lake bed, collecting samples of rock and soil. These samples will eventually be returned to Earth, where scientists can study them with instruments far more sophisticated than anything we can send to Mars. Even if we never find evidence of life, the search teaches us something important. It teaches us about the limits of life, about how fragile or resilient biology can be, about what it takes for a world to remain habitable. Mars shows us what Earth could become. Circumstances changed. If our magnetic field weakened, if our atmosphere thinned, it is a reminder that planets are not permanent, that worlds can change, that nothing lasts forever. And yet, there is no sadness in this, only a quiet acceptance, a recognition that change is the nature of all things. For now, Mars remains still, patient, holding its secrets close. Someday humans may walk on Mars. Not soon. But someday, when that day comes, those first explorers will step onto a world unlike anything they have known. They will feel the pull of gravity, about 1/3 as strong as Earth's, making every step feel light and effortless. They will see the horizon, closer than on Earth, because Mars is smaller, curving away more quickly in every direction. They will breathe air, carried in tanks on their backs, protected from the thin, cold atmosphere by suits designed to keep them warm and safe. And they will look up at the sky and see 2 moons instead of 1, and stars shining brighter than any sky on Earth. At certain times of the Martian year, Earth would be visible in their sky, a bright blue star, distant and small, a reminder of home. But for now, Mars belongs to the rovers, to the orbiters, to the quiet machines we have sent to explore on our behalf. They work alone, millions of miles from the hands that built them, following instructions sent across the void. And they continue their patient work, day by day, soul by soul, teaching us about a world we are only beginning to understand. There is no rush to get to Mars. No deadline for discovery. The planet has waited for billions of years, and it will wait as long as it takes for us to arrive, if we ever do. And perhaps that patience is the greatest gift Mars offers us. A reminder that some things cannot be hurried, that understanding takes time, that the universe unfolds at its own pace. If you could see Mars with your own eyes, standing on its surface, what colors would you see? The sky during the day is not blue like Earth's, but a soft, dusty butterscotch, peachy orange, tinted by the fine particles suspended in the air. The ground ranges from deep rust red to lighter shades of tan and ochre, with darker volcanic rocks scattered like shadows among the dust. In some places, the rocks are almost purple-gray, ancient basalt from volcanic eruptions long ago. The ice caps are white, brilliant white, made of frozen water and carbon dioxide, glowing against the reddish landscape. And as the sun sets, as we mentioned before, the horizon glows blue, a soft, cool blue, surrounding the sun like a halo. At night, the sky becomes black, truly black, a darkness deeper than most of us have ever seen on Earth. And against that blackness, stars appear by the thousands, the Milky Way stretching overhead like a river of light, undimmed by any atmosphere thick enough to hide them. From Mars you could see Earth on clear nights, shining bright in the sky, a blue dot among the stars. You might even see the moon, barely visible, close to Earth. Two companions traveling together through the night. The colors of Mars are soft, muted, gentle on the eyes. There are no bright greens or deep ocean blues, no vibrant forests or flowing rivers. But there is a quiet beauty in the simplicity, in the way light and dust and rock combine to create a palette all its own. We have traveled far tonight, across millions of miles of space, to visit a quiet, ancient world. Mars waits there still, turning slowly beneath its distant sun, wrapped in dust and silence. It does not hurry. It does not worry. It simply exists, as it has for billions of years, and as it will for billions more. There is something comforting in knowing that Mars is out there, distant neighbor, patient and still, following its orbit through the darkness. As you let yourself drift towards sleep, carry with you the image of that rust-colored world, the blue sunsets, the towering volcanoes, the ancient river valleys. Let yourself float gently, as if you were looking down at Mars from high above, watching it turn slowly beneath you. There is no need to think about tomorrow. No need to solve anything tonight. Simply rest in the stillness, in the quiet company of a distant planet, in the vastness of space, where time moves slowly and everything is exactly as it should be. Take one more slow, deep breath in, and let it go. And now, let yourself sleep.